Okay, perfect. So, oh, I forgot to do the old check-in like last time. So firstly, out of the people here currently, how many, please show, a thumbs up or anything if you were able to do the first parts of the bonus assignment, the regular parts, not the advanced ones. Ooh, 2.
What was the question?
Yeah, just the people who have done the bonus assignment, just the regular part.
You mean the one that you sent last week?
The bonus assignment 2, the second one, the one I displayed here a bit before about the Pascal's pyramid.
Oh yes, I did. Yes, yeah, okay. Sorry, I was confused. Yeah, I did it. I didn't submit it, but I did it. I haven't finished though.
Oh, nice. Okay, great. Did it up to the recursive. Yeah, the recursive part that's the fun part. That's a shame that you stopped there. But we can get there later. Bada bing. Let's go. So, bonus assignment 2. Firstly, I can spend some time just making sure everyone understands this concept of the Pascal's pyramid here. So essentially, what
triangle. It's technically triangle? Pascal's triangle, not Pascal's pyramid, because Pascal's...
don't.
All right.
Okay, it probably is.
I agree.
You're probably right. And if you Google the solution to this, that might be a sign. No, but it looks like a pyramid, so therefore Pascal's pyramid is what we were going to call it. No, but essentially what it is, it's a triangle or a pyramid or whatnot generated by numbers. It's not more difficult than that. The first level of number is 1. The second level is the sum of the previous levels, the diagonal sum. So you can see that in this case it's just 1. And on a third level, you see that nothing plus 1 equals 1. And then we get to the middle part where you see that 1 plus 1 equals 2, which gives us this number. And then you go for each level doing this procedure. You can see here that 1 plus 2 equals 3, and then 2 plus 1 equals 3, and then you go to the next, no problem, and we continue like that. And the only thing we're asked to do is firstly, if this is row 0, the first row with just one number, we're supposed to print what row, or rather we're supposed to calculate what row 0 will look like, and then we're supposed to print the whole pyramid, but they cannot go hand in hand. So here we are, a simple clean object, a simple clean class, sorry. Where do we go? And don't be shy like usual, raising your hand and stuff. It's probably good, but I don't have the second screen, so I can't see if you're raising your hand. So this, while we're waiting for some brave soul to step forward, this exercise kind of drops you in the dark here. The previous one, I kind of gave you a code structure. We created a little nice classes here and there with the main class and etc., which you could work in. Here you're kind of stranded, but hopefully you feel comfortable enough after the first assignment and doing your own coding, comfortable enough to get started in here. Do you have any suggestions on how to do this?
Okay, I didn't know this was interactive.
I hope I warned about that.
Okay.
I'm not gonna do any kind of theoretical stuff here. I'm just doing coding.
Okay, so since I didn't attempt this, let's do it together then. So concept hints, array, for loop, and string builder. So I don't know, I would start by trying to see if a for loop would work.
Diana, a good indication is to look at the first question and like see what it's asking us to do. And in this case, it's asking us to provide what the 20th row would look like. So
yep, I know. But I guess in this exercise, do you need to create the pyramid first in code, or can you start already with one?
I think it would be easier to start with an int number of rows equals 20 or something along those lines.
Okay.
Probably we need 2 for loops, like one for the row and one for the column.
Yeah.
Yep.
Okay, so we don't need to construct the pyramid, we just go directly for the row 20.
2 for loops, you said?
Yeah.
Like this?
Nested for loops.
Ah, nested for loops.
Nested
Okay.
for loop.
I'll stay out of it a bit.
Oh God, I accidentally, whatever. There we go. Bada bing. So nested for loops, interesting. What are we trying to achieve with these?
First one for representing the number of rows, say int I is equal to 0.
Okay, something like this.
Then R less than nr rows dot length.
Length.
nr plus plus.
Like this.
Hmm?
And the one who's
Yeah, but we have,
with this.
no, I mean, I know the answer, so.
So I think the compiler's complaining here. Can't resolve symbol length.
Yeah, is it size?
It's a primitive type. It's an int, so.
Ah, it's a primitive type, which means that it doesn't have any methods, right? It's just an integer. Mm-hmm. Okay. Nice start. Where do we go from next? So this will go through the rows. We can try to visualize this while we wait for bravery to step up. And I can't actually, this is amazing. The zoom window is in the way of the shaft, so I can't remove the shaft currently. Right?
Cosmin says you should be declaring fields.
Declaring fields, okay, great. What more fields do we need? Or, well, these aren't really fields, what we're doing currently, and these are just what? Do we know the terminology here?
I think we have to make a for loop inside for loop. The second one maybe start from 1. And this is from 20. The second one will be from 1 to 20 plus 1. So 21 for integer.
Mm-hmm.
For example, j equal 1. J less than 21 minus j, or minus 1 minus I maybe, and j plus plus. Yep.
Like this, or do you say something else?
Shouldn't we run the second loop?
Minus I, 21 minus I.
Minus I.
Yes, I guess like this.
No, it's
you mean
just,
R?
it's just less than or equal to I, because we need to run the columns.
I mean R is R here, not I. 21 minus R.
Oh, absolutely. Sorry, I opened up the annotate window here. -r. Okay. So then I heard someone disagreeing with this, wanting us to do something similar to this.
Yeah, I think it was Radha who disagreed.
Yeah, I was saying that it's j equals 0 and j less than or equal to I, because we need to run the number of columns with respect to the rows.
Okay, okay. It's probably good to have a common understanding of what we're trying to do here. I think both alternatives sounds very viable.
Maybe you can put comments next to like what the for loop's representing, Johan. Like the first for loop we know it's representing the.
I was gonna try doing something like this, perhaps as well. Well, you will have to excuse me because this pyramid is gonna get ugly.
You gave us some leeway with the large numbers. We'll give you some leeway with the drawing.
Yeah. So previously I didn't give leeway with the large numbers actually, so that made it a lot more sadistic. Okay. So we said that this row equals 0 up here, right? And that it's we can just call it r, so then r equals 1 here, r equals 2 here. So then we're defining something called j. We could also call it perhaps c for column, I guess. What is j representing here?
Column.
Column here.
The column, okay. And so what would j be on this number?
I think it should be 21 minus I. It is just R there.
Yeah.
21 minus R. I didn't get that.
So for this one, you say that j equals what?
It's j equals 0, j less than or equal to R. Just R, not 21 minus R.
Less than or equal to r, okay. Wait 1 second. I'm looking like this.
Yeah.
I'm just trying to understand here what we're trying to do when we're doing this. So j is somehow referring to column, I heard from people, but let's think about that because this looks very difficult for a pyramid with this shape, right? What will like j be for this first value if r equals 0 for this first value?
J equals 1.
Sorry, j equals 1.
1, yes, maybe 1. Yeah.
Oh, I see the chat has a lot of. 1 second. So then the question is, sorry?
If we consider the formula which was written, the condition which is written in the second for loop, then it will be 0.
Okay, so this will be 0, you're saying?
According to what I've been suggesting.
All right. I think this, in general, is very difficult to play around with when we try to draw things like this. Another way we could start thinking about this is perhaps
list.
In the matrix, you mean?
XY.
Yeah, beautiful. I heard the word matrix here.
Yeah, but just brainstorming out loud. So right now we have 6 rows, right? And for every new row, you'll have a new column as well. So the pyramid grows like that. So if you have 6 rows right now, you have 6 columns. And if we're gonna do 20 rows, then we should have 20 columns.
Okay, so 20 columns. That sounds very promising, what you're saying. But let's try to think of it this way then. Perhaps we can build a pyramid initially. So here we have the row, right?
Yeah.
Row equals 0 here. Col equals 0 here.
So it's like a XY.
Yeah, exactly. It all comes back to this, right? So let's say this is where the pyramid starts. Setting this as 1. And let's say this continues, r equals 1 here.
Yeah.
Column equals 1 here. And let's say we're growing it along the rows, right? So what will the next row here look like?
Like
1, 1, 1.
0.
And then 1.
Ah, nice. Yeah. And what would the third row look like?
That's 1 to 1.
1 to 1.
Ah, now suddenly we have a lot easier way of thinking about this and seeing what the different C values are here, right? This is one way to go at it. That's 1,
3, 3, 1.
Beautiful. So let's move this to the side here. I think we're getting the principle. So this is our option 2 when it comes to thinking about this. I just wanted to provide the tools for the people because this one helps a lot when visualizing this. But okay, I'm back to being silent again. Sorry.
Nice explanation, Johan.
Well, any takers? J is less than or equals to R. Is that good? Would anyone want to motivate why it should look like this?
No, so following the principle, we're gonna have to print 20 rows, right? And we always stop at the last. So I would put J is less than 21, so that it would stop on the 20, the iteration.
Less than 21, okay.
Without the equal. That's my suggestion.
All right. I'm just gonna quickly correct this to mean 2, of course. Nice. All right. And why do you suggest we're doing it like this then? Diana?
You mean the 21 or the
Yeah, exactly.
inner loop? Because we're going to print 20 rows and we always start counting with 0, right? So 0, 1, 2, 3. Okay. So it's always going to be the final.
What is it we're counting here with J currently? Perhaps we can rename this.
Sorry, the columns, yeah.
Yeah. We'll start with doing a simple rename so it's easier to visualize here. Nice, the columns. And you're saying 21 because what?
Because we want to iterate from column 0 all the way to column 20, right?
But then my question to you is, do we need to iterate 21 times here for the first row?
Aha, okay, no.
Okay, no?
Or I don't know, let me think about it.
Yeah.
Yeah.
Anyone feeling confident?
I think if she excludes C, if she excludes 21, then it's... yeah.
Wait, sorry, one more time.
It would be 20 instead of 21 if we want to iterate 20 times.
Okay, so in general principle, I'm gonna force you into now is if you're writing these numbers here, always try to make sure they refer to some kind of local variable you have defined before if several places are using this variable, right? So here we could just say NR rows. And if we ever want to change the amount of rows we want to print to, let's say, 25, we can just do that and the algorithm will still work, right? Instead of having to go through all the code and finding every place. But yeah, this looks good.
Right.
Nice. Okay. All right. So let's say we're doing this. Let's say we're iterating 20 times. So all the rows and then all the columns. What are we doing during these iterations?
We have to print something.
We have to print something.
We have to.
Okay.
What's that we print?
Yeah. What is it that we're printing?
This is the trick. C or
We need a formula to build the Pascal's triangle.
We need a formula. Okay. What would that formula be?
We can initialize the first number to be 1.
Okay, should we write this here? Something like this?
Yeah. First number to be 1. And then inside the for loop. Yeah, the next line.
Yeah.
You can write the formula to find the next 2 numbers in the second row.
Sorry, what did you say?
We can write the formula to find the next 2 numbers in the second row.
Next 2 numbers, okay.
Yeah, that's in the second row. So I know the formula because I just tried that. So I can say you that one, but
yeah, sure.
It's first number equals.
So what? Int?
First number equals first number times in the bracket I minus j.
I minus j.
We don't have.
No, sorry. In this case, it's r and c. Okay, r minus c divided by the number of columns plus 1. So in this case, it should be c plus 1. Yeah.
Looking like this then. Now, where did you find this formula?
I know that Pascal's triangle, when I start working with these numbers, I could execute that as 1, 1, 1, 2, 1, 1, 3, 3, 1 when I add them and put them inside the loop.
Okay. So you're saying there is a formula out there which calculates each value here. So no, Pascal's triangle formula. We don't want to search up Pascal's formula. That's a whole other issue for, yeah. Oh. And then we can just look around if we want. If you're able to find where you found this, then sure. But let's go back here. You said first number equals first number times the current row we're at minus the current column we're at divided by the current column we are at +1.
Yeah.
Why is this working?
Okay, suppose if I put the first number as 1, and if I run the loop for r to be 0, and of course the column value also to be 0, then the next value I get would be 1 times 0 divided by 0.
Yeah, which will break, you know.
1 times 1 minus, which is 0.
1 times 0.
That's of 0.
Yeah, I know. Isn't that 0?
Yeah,
0.
0.
Yeah, multiplication by 0 will always be 0.
R minus C.
So the formula is not correct. Johan's
Is that
painting
the
everything with 0 now.
factorial formula?
Okay.
Well, how did we define that the value of, for example, this element, or this element, or the elements above that, when we introduce the triangle?
Every number on a new row is the number of the 2 numbers above.
The 2 numbers directly above, yes.
Okay, exactly. So this is the value of these 2 numbers, right?
The first number inside the for loop, like inside, yeah. Can you initialize that after the first for loop? Yeah, now
Here.
let's try. Yeah. Yeah, now
Wouldn't this cause some issues for us as well? Since this will still become 0, right?
That's fine, but before running the loop again, the number will be initialized as 1 again, the first number.
Okay, so then it's 1, and then for the second row, it would then be what?
Yeah, so for the second row.
1 minus 0, 1 divided by 1, so that's 1.
That's 1, so that returns 1.
Okay, nice. You actually found the formula for this. That's clean. If this actually is working, let's try this for the third row. So let's try this again. This is 2. So then we have 2 minus 0. No, wait. No, sorry, I misspoke. This does not work still, right? No, it does. It does.
It does work.
Ooh, this is so exciting. I don't think I've seen this formula before, actually, when I've done this.
This is what we were using when like we were teaching numerical methods for engineering students.
God. Okay.
Nice one.
I'm actually impressed. Well done. Okay. So are we just done now?
Don't need a print.
I mean, yeah, let's try this. Can't see anything currently. The Zoom is in the way.
You need to print the first number, right? Yeah, in that line, system.out.println first number.
Okay, someone has a bit of music on, and I like it, but
That's a ringtone. So nothing.
So we got nothing right now. Are we done?
No output.
But you need to print the first number. Yeah.
Okay. I'll try this again then. How is my computer this tired? Whoa, what is happening here? Now this is no triangle of mine. Okay, so what's wrong with the current setup we have here?
Shouldn't we run the number of columns with respect to the number of rows? So I think it should be C less than R and not number of rows. It's just R.
C less than R.
Hmm?
I was very excited when I saw someone saying this before as well, because it does help a lot. Let's go down this line of thinking, okay? And then we can start thinking logically about this as well, because I have no idea what this means. And if I'm sure it works, but let's give it another shot then. We're still getting this weird wave shape instead of a triangle. Do you have any suggestions on how to fix that, Rada?
I'm just checking.
So while you're checking, I suggest we try something else here as well. Okay. Let's have two different implementations where we're doing this, because if this one works, it almost feels like cheating. It's so good that it feels like cheating.
Maybe it's a matter of, how do we say,
let's call this our sad implementation, which is not as efficient. Sorry?
Maybe it's a matter of configuration.
A matter of configuration. What do you mean?
How to print the values.
Yes, I think you're onto something there. What is currently happening?
Again?
What is currently happening as you're looking at this?
I'm just trying to have a thought.
Okay, in order to not to take too much time, I will just quickly suggest some changes here, and we can see how that goes. So perhaps we print everything on the same row, but when we're done with the row, we print an empty line, right? I'll make the suggestion now and see how the formatting looks after that, and then we can go to the other possibility, because if this works, I'm just very impressed.
Oh, it worked.
We're closer.
It should be C less than or equal to R.
Or equal to.
Give one more iteration on the.
So we're getting a few printouts here. Please ignore them. Whoops.
No.
I mean, we currently have a few other problems as well. For example, what you can't really defer when it comes to two-digit numbers, right? But as we see, I'm honestly very impressed. I don't know where, well, you kind of told me where you got this formula from, but this seems to be solution number one.
Yeah, it's impressive, yeah.
Yeah, I agree.
When I saw this as a coder though, I had no idea of this. So can we, so for the people who want, just you can replicate that. I mean, I can even show you how to fix the formatting if you want. We can, for example, add some spaces depending on the number of rows.
I don't know how to print that in the form of a pyramid. This is what even I did till this point.
Till this point, okay, nice. What would you prefer? Would you prefer that we solve the formatting for this, or try to write this in a way that we understand it?
Understanding, I think, would be better.
Yes,
okay.
At least for now.
Then we can fix the formatting for both, if people agree with that.
Agree.
Yeah, super. If not, send me a private message. You know, I'm trying to keep an eye there. There we are. So this we can call Math
Super
Master Solution. Yeah, there
Yeah.
we go. And then we have Simpleton Programmer Solution. So there we go.
Non-math master solution.
Yeah. Oh, is this too harsh? Non. Super. Okay, but let's get back to where we were on this solution then. Rada, just plus points for you. Really nice to see
I'm
that.
a math teacher, basically.
Sorry?
I'm a math teacher.
Oh, really? Wow.
But what should, I want to understand, why does the Math Master one works too? Like maybe
Yeah.
you just like maybe explain 5 minutes or something, if that's possible.
What's that?
And sometimes when you don't know how the code works or the values, it's good to use a debugger, which is what I do, to see what values are taken into the variables at all times.
What? No, I asked Rada to explain the formula.
Okay. Okay. So basically, I have fixed the first number to be 1, because we know that for a Pascal's triangle, the first element is 1 with the first row and first column. So then the next row, it should be 1 and 1. So which means the first number in each row, when we see in the Pascal's triangle, is always 1.
Yes.
So I have fixed the first number to be 1. So before my loop entries, every time the first row element will be fixed as 1.
Mm-hmm.
So far, so good.
Yeah. And then once I enter the second loop, that is the for loop, when I put the number to be 1 and start the iteration with R value to be 0 and the column value to be 0, we of course get the first number to be 0 there. But because before entering the loop again, it goes back and fixes the first number as 1 again. So now when I enter the loop again with C value to be 1 and row value to be still 0, so the first number will be now 1 again. So 1 times 0 minus 1 divided by 0 plus 1. And now when I increase the row value as 1, it becomes 1 times 1 minus 1 divided by 1 plus 1, which is 0. And now when I increase the row value as 2 for different values of the column, so that's 2 minus 0 divided by 2 plus 1. I said something wrong, maybe.
For me personally, like what you're saying makes sense and seems to be working, but how did you deduce this? Like, how did you get this? And then did you just adapt it? You tried it out for one row and then another, and then adapt that?
No. Whether it's a Floyd's triangle or Fibonacci series or Pascal's triangle, when we teach students, we have formulas for each of these.
Ah, okay.
So this basically we use when we are doing for Pascal's triangle.
All right.
I think
we have formulas for finding Fibonacci series, for Floyd's triangle, for everything in math.
I think this might be related to what is called a coefficient of polynomial, something like that, if I'm not mistaken.
Yeah, we can do this using binomial series also. That's what I was trying to do.
Okay.
So for the sake of time, and the people watching the recording. What do you say we get back to this currently? But I'd really like to see like the proof behind that formula, if you get what I mean. But currently we can try to deduce this part ourselves. Does that sound good?
Sounds good, Johan. Sorry for hijacking your...
No. I was very curious to hear, but I wish I had the proof in front of me so I could follow it. Anyhow, we are doing this from scratch. We don't have this formula. What do we do? Anyone brave?
I don't know. I guess the less intelligent way is to just do everything manually and print every row and every column manually.
Okay, so outside of us writing a system that outprint, I don't know how many times, 20 times, and calculating that ourselves, I think we can do this within the loop though, and it's so there's a few ways. You could take a look at the advice I gave in the exercise. You can use a string builder, for example, for each row if you want. I'm not sure we have to do that. But we somehow, the only knowledge we have is that this value here is the basis for the value of these two, right? And for the 2 here, the basis are these two values, correct? So 2 equals 1 plus 1, and 3 equals 1 plus 2. So we kind of have to have some kind of we have to have knowledge about what these values used to be, right? Do you agree with that statement? And what can we then do? I saw one person writing yes, and that's good enough for me. So if we want knowledge about the previous elements here, is there a way for us to get that knowledge? Because the first iteration we will start here, then we don't really need any previous knowledge, we just know it's 1, right? The second iteration, I mean, one can say that these just start as 1 and 1, right? They are the interior of the triangle. But you can also just look at this one and use that as prior knowledge. But here, at least here, we start needing some way to store the previous row so we can look at it. And what could be a nice way for us to store
Array.
a row? Oh yeah, I heard array. And how would you like to initiate this array?
Just put array.
Okay, array.
And then, or is it the name first and then the name?
Oh, I mean, this is good enough. This is just a regular array.
It's okay.
Is this good enough?
Don't we need to give a name to the array? Or it's fine?
Currently, this is the name of the array.
Okay, sorry, yeah.
Is this enough? Have you worked a bit with arrays before?
Yeah, but I'm not sure if we need a normal array or a 2D array in this case, for example, since we have both columns and rows.
Whichever we want, actually. We can perhaps have a 2D array, but let's, for the sake of how we want to do this right now, keep it a bit simpler than creating a 2D array, right? Yes. Well, it's up to you. We can have, so the 2 suggestions I'll give to you here and then you get to pick which one you prefer, is either either that we create an array looking like this. Let's see if I forgot something here. No. Have I forgotten the syntax? No, I haven't. Perfect. And then we have so these two are our options. Option 1 is to use an array. In order to be able to remember the previous row when we're calculating the new one, we need to know this row, right? If we're going to know this row, we have to know what this row looks like. And if we are going to calculate this row, we need to know what this row looks like, because the values are based upon the other row.
Okay, maybe I'll just make it simple and do the normal array.
We could do a matrix and store the whole thing, as you said, but currently it would just be, you know, a waste of space, honestly. We don't need that much space. And we really care about performance when we do things in Java, right?
Yeah.
So what should this array's size be? Did I hear 20?
I had a 20.
20.
But I didn't hear a 20. I heard n rows. So we can easily adapt it for future.
Yes.
Is it fine if I move this lower so it's easier to look? There we are. Okay, great. Let's say we're using the array now. What shall we do during each iteration here? Is there something we need to do with the array initially?
Don't we need to fill it up?
Fill it up, okay. With what?
The values at each point of the matrix, at each index.
Okay, sure. So you're saying when we're currently executing, let's say we're on row 0.
Yes.
We save this into the array somehow. How would we do that?
Add.
Add. You see that it doesn't have an add method because we're using arrays, I hope.
Import.
It's very important to have some experience using arrays. So I'm going to show you this now. If you want to access elements in an array, you use these clammers here. We've been so spoiled using, you know, lists and array lists, etc. But this is the the fundamentals we have to go back to.
Equals to.
So you can write array 0, for example, to access an element, and then you can write. Okay, so the element in position 0 of this array. Let's say that this is our array, right? Element 0 at this array equals to what? One, I saw someone write. Okay, let's do that. Okay, nice. Now, okay, so we run the program. Okay, will this program we're written now print? What will it print?
Just one.
Nothing at all, right?
Oh yes, because there's no print.
Yes. So do you want to print something? And where should we print something?
After the array.
After array, okay. What should we print?
Print array. Array.
Can we, for the sake of helping us understand what we're doing, perhaps this is to help us understand. Let's call this previous row, right? Does that sound good, or do you want to keep the array name?
That's good. I'm back.
Yeah.
Previous row. And then we print the previous row. So let's try this program out. This is such a nice iterative way to do things. Run. And we see that our solution will give the beautiful mess of outputs we have here currently.
Yeah, given the.
So a warning here, when you're trying to print things from arrays, we don't have the luxury of lists anymore, right?
Yeah.
When we're trying to print something from an array, we get the address once again. We call it.
We have
Want something?
Yes, row dot get value maybe. We have dot something to get the value.
So this looks like this was a good territory that we have missed out on, because using arrays, it's important to know of them and how to use them, because it's a very fundamental data type, which is used in many other programming languages as well. So if you want to access elements in an array, you can't do anything like .get or something like that. Oh, it's called previous row, sorry. You can see here the methods we have available. I don't see any get method, right? We can clone it. We can do scary things called stream and see dot equals, but the only way we can access elements is by specifying where in the array it's situated using these. So,
Index.
for example, previous row 0 equals 5. Or if we want to print it, we want to print the first element, we write row. Previous row 0 like this, and we actually will get one row. Yes, we'll get the first element of that array 20 times or more actually.
Yeah, because we're looping.
Yes, so what are we doing currently? We're going through this triangle. For each value we're looking at, we're printing a 1. We're setting the value of this first, the first value of the array to 1, and then we're printing a new row with that value for each row and for each column we have. So that feels a bit off. People are very silent. Is anyone willing to guide us here?
I would love to guide, but I have no idea. So.
Okay.
Okay, I'm gonna guess. Don't we have to? Okay, so now we're printing only the rows, right? Don't we have to index the rows instead of putting 0?
Index the rows? What do you mean?
So like, I don't know, put C there or put R.
We need the variable to print.
But okay, so what was the purpose of this previous array we created?
To store the the number of the previous row, right?
Yeah, but for here, we're going through each value of each column, right? So
Yes.
is there a need to print the previous row? Or was not the purpose just to store this so we can easily calculate what the row will be next time?
Store. But we need to print the first one, right? Like the 1 and then maybe the 1, 1.
Mm-hmm.
The first and the second row needs to be printed. And then after that is just store.
Okay, but it's good. That's good. So the matrix approach would be kind of easy. We just fill the matrix and then we go through all the rows and all the columns and print all the values, right? That could have been done quite easily, but we chose the performance optimized way here. But let's skip printing the whole array here, because that's going to be an issue if we're going to try to do that with the previous. Well, it's not going to be an issue per se, but we're going to get a lot of ones and zeros unless we specify things a bit more. Sorry, let's do this. Previous row 0 equals 1.
Can I ask a question regarding of this?
Mm-hmm.
Why now it's working? Previous row C, it was printing the address. Now, what's the change?
Sorry?
It was printing the address of the array. So now, what did it change to write the 1, 1? Actually, I didn't catch because I have some troubles and connection.
Okay, so important to know when you're using arrays is that you have to access it using these, I don't know, I call them clammers, and then write the index in the array it's stored. So an array,
okay.
when you're using an array, I'm going to draw down here, you can imagine it looking like this. You have 0, 3, 1, 5, dot, dot, dot. It continues for a while here. So this is array. It looks like an array list, right? This is how we visualized an array list before. And this is because an array list contains an array in it. Like this is the fundamental data type. And then we have built like a class around that. Mm-hmm. So when we write, for example, this colon 5, we go to 0, 1, 2, 3, 4, 5 and find that element. And this is something you should have experience using. So I'm sorry that it takes a bit extra time doing this, but it's important that you know how to use an array, in my opinion. I'm sorry if you're hearing noise in the background. Here we are. Okay, but let's check this condition. We can, you know, in my opinion, these first two rows are kind of difficult to think about, right? Let's say if the row equals 0, we don't do anything, right? We just we can just system.out print 1, right? If we're on the first row, we can just print 1. We don't have to think any more than that, okay? Then we can perhaps do the same thing for second row if r equals 1, because these are what we call edge cases, right? It's hard to write an algorithm which applies for all of these. So what you can do then is just let them be handled elsewhere. That's a very easy approach to doing this. So perhaps 1 and 1, looking like that. And so currently we don't really have a triangle, right? Because we're just printing 1 and 1, and if we run this again, the first 3 prints we'll have will be 1, and then 1, 1, so we'll have 3 ones in a row. So the way to get around that is that by the end of each row, we can just print an empty row, right? We change to the next row. Okay, great. So now let's get to the actual scenarios here.
Don't you need a bracket after the first if as well, or?
Oh, sorry, this is just me cheating. Java allows you to skip brackets if you're just doing 1 row after an if statement. Or an
Okay.
Yeah. So if we just wrote 1 row after the else, we could do that here as well. But it's the same thing. And if we write, for example, R++ here, you see that Java immediately moves it here, showing that it's outside of this if statement.
Okay.
Well, IntelliJ moves it right there, sorry.
Okay, so then the else would be the continuation, right? So else row greater than 1.
And I can, if else row greater than 1, yeah?
Yeah. Am I talking nonsense now? I don't know. And then we're gonna do a formula to do the calculation, right?
Well, yes, okay. I'm just thinking how to approach this in a good way.
Yeah, I was just following your logic. So 1 and then 1, 1. So, but don't you need to, so how do you then iterate with the number of rows?
And you can see here also one of the problems we have currently is that if columns, if we're on the second row, right, we're gonna do this 2 times. Okay, never mind.
Yes, exactly. So
yeah, well, we should do this 2 times, and then we'll print 1, 1, 1, 1. So this approach isn't very good either. Plus,
we can print everything before the ifs then.
Before the ifs, yeah.
All right, even before the 4 even.
This is going down the right track of thinking, but we're currently going through each of these columns, right? So like, I know how to do this. I'm just thinking how to get there. Perhaps it's just better to show. Let's think of this loop currently. We're going through the rows, right? Row 0, row 1, row 2, etc. So we're gonna go through 20 rows, which is exactly what we want. How many times will we go through each column? Let's think of the edge case here. We're at row 0 and we're at column 0. Then we go to the next row. We're at row 0 and we're at column 0. Is the column 0 less than the row 0? Ignore all of this. Like, it's good, but ignore it currently. Like, it's not here. The column C, when we're at the first case, is the column C less than the row value?
No, it's the same, right? It's 0 and 0.
So this will never execute, right?
No, exactly.
So we'll never get the 1 printed.
No.
That's a problem. How can we solve that?
You can start. You can put a starter, so you can change the row to 1 if you want. That's a way as well. I guess.
But if you look here, aren't you going to have the
True.
same problem later on?
True.
Yes.
How do we get around that?
Less than or equal.
Ah, beautiful. What does this do? Now we can see that where the column and row is the same, which they will be along this whole line, then it's fine for the loop to continue, right?
Yes.
Right.
Perfect. And now we can think of the edge case scenarios here, because it's not only the beginning, which is an edge case scenario, rather the problem you can see here along the whole first column and along the whole diagonal, the edge case scenario is that they always will be 1, right? So
Yes.
instead of comparing the column then, we check if the row is equal to 0. No, the column, no, instead of comparing the row, we can check
Compare
if
the
the
column.
column is equal to 0. Then we should do what?
You can also compare the row if you access the first item in the row and the last item in the row.
Yeah, absolutely. But okay. Sorry, 1 second. Sorry, there's people in the room here.
KTH.
Yeah, I'm still here. I'm hoping to get back to my home eventually, once they release me. Anyhow, we have different edge case scenarios, but let's say for the first row, it's important to think about these edge case scenarios because it makes things easier. But what we in general want to do when we go through a row is that we want to store a value there, right?
Yes.
And at what position should we store this value?
Sorry, what value? The 1, the first one.
Yeah, so let's say
0, 0.
Yes, and when we're going through this one, so for the first one, let's.
Yeah.
I'm sorry
0,
that I
1.
added complexity to this. I think I see how I can make this easy for us to think about. Okay, so first row, we're setting the first element here to 1, right?
Yes.
And we can try to print in Firstly, let's do some simple calculation. We want to find this value we have currently. We're at row 0 and column 0. So int val equals what?
1.
1. Yeah.
Well, how did we define this before? When we said, well, it should be 1 on the first scenario, but when we go to the, I'm sorry, it's people written chat. Yeah, so when we go to the bonus element, how did we define the pyramid or the triangle? We define it as the sum of the 2 values above, correct?
Yes.
Mm-hmm. Good. So int val equals what? The sum of the 2 values above. Okay, I've dragged this out long
So
enough.
previous role and then index something. I know what you want to do, but I don't know how to implement it.
I like your way of thinking here. So perhaps
yeah, previous role plus previous role. Yeah.
We want two values from the previous row, right? What should these values be?
It starts with
At the first and the last index?
no, 0, 1, 1, 1, right? Or 0, 1.
0 and 1. Oops.
I think so. But now I'm thinking in my head in 2D arrays, but it's probably wrong.
So we can imagine this, you see here, the bottom row of this little matrix we created. This is the previous row, right? Let's imagine that. And let's start with this general scenario here. This is the previous row, correct? What values, when we're at row 2, column 0, what values do we need to use now?
Yeah, correct. It's 0, 1. It's correct.
Row equals 0, col equals 1. No, I did a baddie again. There we go. Nice.
Rows equals 2.
So this is the first iteration we're doing. Row equals 0, right? Col equals, no, row equals 2 and col equals 0. We're here. And this is our previous array, correct? What position do we need to access?
Cosman says row equals C plus 1.
1, 0?
Oh, sorry, I missed the chat. Row equals C plus 1. And I heard 1, 0. 1, 0 is correct, yes. So essentially what we've written here. And let's take a look at what was it? Was me? Yeah. C plus 1. Okay, no. You're on the right track because these values are correct. But if we just write 1 and 0, this will not work. What is this relation to these two values? Let's say we go from this row now, or from staying at this row, going to the next column. So now row equals, here, row equals 2 and column equals 1. What should interval be now?
2, 1, maybe?
2, 1. Like this. So you're saying, what is that? What is it we're retrieving currently? We're retrieving, for this one, we retrieve value 0 and value 1. Right?
Mm-hmm.
Now that's a problem because then we should have a 2 here, right?
Yeah, okay.
Which means that, and doesn't that happen here as well? Let's say the row is equal to 3 and the column equals to 0. Won't that be the same problem here?
Oh, yes.
If you take these two, you'll have the same problem. This will be a problem essentially anywhere. Because you see, let's think about the 2 scenario. Hold that thought. Okay, now we're getting somewhere. For the 2 scenario, which elements should we access? So row equals 2, column equals 1.
Sum of the previous row. Sum
Yeah.
of the previous row.
So now perhaps we can do what we said before, 0 and 1, right? And let's go to this element now. So we are at row 3. So we're at row 2 and column 2. We want to calculate this value. How do we do that? Well, we can simply just look at the same way 2 did, right? 2 looks at the pyramid. In this case, it looks at 1 and 1. In this case, it looks at row 1, column 0, and row 1, column 1. And where we're calculating this, we can look at row 1, column 1, and row 1, column 2, right? Because this will have the value of 0 if the array is empty. So looking something like that. So let's apply this thinking to the third row now, okay? So we have row 1, row equals 3, and col equals 1. No, col equals 1 here, so we're here. If we do the same thing now, we take 0 and 1, we will get the correct value, right? And if we take a look at this one and do the same calculation on this place, so row 3, column 2, we will see that previous row will be this row. So we'll take previous row 1, which is 2, plus previous row 2, which is 1, and get 3, just like this scenario.
Yes.
And then we can do this. Then we have to unfortunately add a third thing, this whole column here, which is when row equals 3 and column equals 3, because now we have 3 columns here to think of. And then you can see that if we just increase this by 1 again, suddenly it's working, right?
Yeah, but but aren't we going to have to increase every time we increase the column? So we're just going to have to keep doing this until...
Yeah, so this is very unfortunate if we just write all of this within this first for loop, right? For each row, we just add this whole calculation. That's very annoying to deal with. So luckily, we have a nested for loop, which allows us to make some nice formulas for this instead. So what is the pattern here? Can anyone see a pattern between these? When r equals 3, and col equals 1, we have to set the value to 0 and 1. And then when this r equals 3 and col equals 2, we have to set the value to 1 and 2. Any taker?
Yeah, so like if you look vertically, previous row increases by 1.
Yeah,
So,
alternative rows, sorry.
Exactly.
Yeah.
And the second one also increases by 1.
Okay, nice. So perhaps we could summarize what you said here with something looking like this. Int v equals to previous row something plus previous row something. Whoa, sorry. There we are. Where this is dependent on the column somehow, right? Because when the column is increasing, this value is increasing, right?
Yes.
Perfect. So when the column equals 1, what value should this be then?
C minus 1.
1 minus.
I heard C minus 1 here.
That should be C.
And this should be C. Beautiful. So if we remove all of this, let's try out our little formula here. We have the previous row, and we check, let's say we're on row 3 again. Or let's start with row 2, and we're looking at column 1 here. So column 1, we're taking this element here. Let's see, okay, perfect. There's a 1 here. So then we get the column is equal to 1, and the row equals to 2. Column equals to 1, and we say 1 minus 1 equals 0. So we get previous row 0. And then we say column, which is 1, we extract that from previous row, which is 1 here. And then you add those together to give us the value 2. And then you move to the next value and check previous row, and we're currently at column 3, no, sorry, column 2. So then we take 2 minus 1, get this value, and then 2 here, which is 0, and then get 1 plus 0 equals 1, right? It takes me, oh God, I looked at the chat. Don't worry. I probably could have done this a lot more efficiently as well, so don't shame me for this. But I think we're onto something here. But what happened when we try to apply this formula here? When column equals to 0. C equals 0.
This becomes negative.
Yes, and what happens if you try to access a negative number in an array?
Error.
And we don't want errors, do we? So then we need to check here. If let's declare the value outside of here first. Let's call it v, because we'll use that now. There we go. If, what should we check then to make sure that this does not throw an error?
The value of C. If C equals 0.
Yeah.
Yeah.
If C equals 0, should we then do this?
No, we should give the value of 1.
Okay.
Yes.
Perfect. And then?
Else.
Yeah.
Then we apply that formula.
Okay, nice. Now this is looking like something. So now we have this scenario covered. All of these will be 1, as we said before, right? So this is no problem. And these other values, as we saw before, will now be calculated using our precious little formula here. So what should we do then in order to display this? I saw someone write V.
Yeah, print V.
Print V, okay.
Can we print V?
Oh, print V.
Yes, yes.
Yes, okay.
Yes, print V.
And is that enough? Are we done now? Did we solve this? Let's actually try to run it then and see what we get. Let's debug this.
Yes, I think so.
Yeah, good. Uh-oh. Uh-oh. Oh, sorry, I added a system print ln. We should not have that. Let's try this again. We're still seeing some worrying signs already though. And I'm very curious to find out what might be causing this. There we are. We're getting a bunch of zeros here. Why is that? We have to add what, Cosmin?
Yeah, I want to ask if there is any difference between C equals R minus 1 and R equals C plus 1. So we use,
Instead of having C minus 1 and C, we have C and C plus 1. Is that what you're saying?
yeah, if there is any difference between C, our formula C equals R minus 1, and the other formula like R being C plus 1, maybe we won't have so many zeros, and I don't know, just like maybe we can try.
Let's think about this for a second.
Sure.
So what if we are at column 1 now, okay? And we're trying to access the elements of the previous. When we C equals 1, we access element 1, we'll get 1. C equals 2, we'll get 0, right? C equals 1 plus 1, we get 0. So this would be 1, which would give us something wrong. But it is possible to do what you're saying, but then we'd have to add an extra row here with zeros, okay? Then you could do this, but currently we're going outside of the bounds of the array. We're shifted one step, and this is always a problem when you're doing nested loops and trying to access elements in arrays, and you will be driven mad doing this. But I can give a hint of what the problem might be here. What is the previous row, the first iteration? When we're at row 0, column 0, so R equals 0, column equals 0, the code starts here. We get to this if statement. What will C be equal to?
0.
Yeah, so then this will execute, and B gets the value 1. Then we print V, so we print 1, and then we start the next iteration of the loop, okay?
You should have an iteration somewhere, an incrementation somewhere.
Well, if you hold that thought a second, okay? So let's say we start the second iteration of the loop now, because there's only one column, right? Because then C becomes 1. 1 is greater than 0. So then this does not happen, and R becomes 1. So now with row 1, we start with C equals 0. C equals 0 becomes 1 as before, right? Because, sorry, I went a bit too fast. This first other iteration, R equals 1, C equals 0. C equals 0, so this is true, which means V equals 1, and we print a 1. Now then, second lap on this row, we see C equals 1, R equals 1. R doesn't matter currently, so C equals 1. This is not true. So then we go to the else statement. Let's see, B equals previous row, C minus 1, and C. This formula was correct, right? But what is the value of previous row? 0. Apparently, according to the program, we're getting 0 back. And the easiest way to know what the value is at these places, well, the easiest is to do what Kibena did and just, debug. But, we're simple coders here. We like system out print. Let's say we write, let's try this out. Let's see the first scenarios. Previous row, and C-1. What will that be? We don't actually have to calculate that. Plus X1. Then we do what? Equals 2. And what does it equal to? Well, it equals to previous row C-1. This is what you should always do when you're having difficulties like this. Just print and see what the values are of the variables currently. Let's do the same thing again, but for the other row. So previous row C equals previous row C. Let's see if anyone in chat has figured this out already. The debugger will help and printing will also help. So let's see what the previous row values are when we try to run this program. So let's go to the starting values here. So when we're at the second row, okay, so good. We found this place here. Yeah. So at the second row, we see that the value of previous row, 0, equals 0, and previous row 1 equals 0 as well. But the previous row value here was 1. How does it come that the values in the array are 0? And if you look here, you can see that previous row values are all 0, all the way down. Why is that? Anyone daring? Sorry that this takes so much time. I'm just gonna rush this now because, it might take a bit too much time otherwise. So
Yes.
if no one feels comfortable. So where do we set the value of the previous row elements? The answer is we never do. So we have an empty array which we're looking at constantly, but we never actually set the values of that array. And this is what this output hints at. Every value in the array is 0 during all of the iterations because we never set the values. And how would we try to set the values? Now I'm gonna need someone to volunteer here. How do we set the values of the previous row array? Okay. Someone wrote here.
Okay, someone wrote. Isn't it previous row dot set and then value?
No, because we're using simple arrays here. So then you just have to do like Sujan mentioned, you just write some kind of index here. I don't know what we want to call that.
Okay.
And that's equal to something. What should the index and something be? Zero equals 1. The index 0 equals to 1. And we can see that when we are at index 0, the value v will be equal to 1. So you're saying we should put something here, such as v. Well, if I may propose a solution, we can try to, since
0.
there's 0, but for every iteration,
Oh, yes. Yes.
we want this element to be something, right?
Yeah.
Not.
Yeah.
So for every iteration, the value,
Should increase.
the index of this value should be what? Remember, let's use the graph here again. This is our little graph. Yeah, the pen works perfect. Let's say we're on this row, we're on row 2. So our previous array is 1, 1. The previous array is 1, 1. Then the new value of our array perhaps should be the value we have calculated here, right? The index is always changing. Yeah, exactly. Okay. See ya, Diana. Okay. So this is it. I'm sorry that I'm taking so much time with this, but it's very important to get the thinking down. And so every iteration, we have calculated what the value will be every iteration using our little algorithm. That's no problem. But we have to also calculate what the index will be every iteration. What should the index be? We're at row 0 and column 0. What should the index be then? If this is our array.
We have some comments from Martha and Raleigh saying it's 1.
The index should be 1. Well, it's the first element, but we index by 0 in programming, right?
Yes.
Yes. So it should be 0. And during the during the second iteration, we can see that here it should be 0 as well, right? But here, the index should be what?
1.
1.
1. And we go here, we can see 0, and it should be 1. But what should the previous element for this one be?
2.
And we can see that it should be equal then to the column number we're at currently, right? Do you see? However, remember, this is a pain. We index from 0. But that's okay because we actually set this to c equals 0. Yeah, perfect. Yeah, nice. Clean. We did it. Yeah. Nice. Super. So will this work now?
We have
Should
to
we give this a try? Ah, excellent. What can go wrong?
Oh la la.
Uh-oh. 1, 2, 2. 1, 3, 5, 5. Why isn't there a 1 at the end of each of these? Yeah, we're so close now, but there's something going wrong here still. This is going to be a long recording for the people who's going to watch this later.
Yeah.
Okay, I'm sorry that I'm taking so much time. I'm not going to tease you anymore. The current problem we're doing is that the array we're manipulating here, we're changing the value. Let's say we're here currently. This is our previous array. We're changing the value. No, let's take this scenario, okay? So let's get my notes out here. There we are. Okay, so this is our previous row. This is where we're at currently. We're calculating 3. So 3 equals to this element plus this element, right? 3 plus 2. So then it equals to 3. So then we set our previous row. Our previous row is originally looking like 1, 2, 1. Then we start this new row. And when we're doing this, we're setting it to 1, 2, 1 during the first lap. But then when we get to 3 here, we're setting it to 1, 3, 1. And then we move on to this 3, all right? Then we move on to this tile and calculate. But then suddenly this says 3 here, right? So it calculates, so we have changed the array value before the calculation happens. Do you see the issue we're having here? Chat. Okay, perfect. Someone said yes, that's good enough for me. So what we're actually doing here is that when we're looking here at this 3, it sees the 3 we have stored here in the previous iteration plus 1 and gives the value 4. And that's completely wrong, and then it gets wrong all the way down. So can anyone suggest an easy way to get around this? We don't need to subtract anything, don't worry. The easiest way, in my opinion, to do this would be whenever we start a new row, we write that the previous row, bye-bye. People going home. Oh, I wish. No, previous row equals to a new row.
Yeah, yep.
You see what we're doing now? We're just creating a new row every time. No, wait, sorry. Now I said the wrong thing. Yeah. We're almost there. Now my brain actually melted, sorry. We're manipulating the values
The previous row is going to be the new row.
Previous row is going to be the new row.
Now, when you go to the next row, the previous row is going to be the new row of the previous one.
Yeah, we have to store a buffer of the old one, right?
Exactly.
Exactly. So, previous row is the one we're using. So perhaps call this new row equals to previous row. And then we say that the new rows element, new row C equals new value.
Yes.
All right, clean. Is that everything we have to do? We have not forgotten anything? Okay, I'll just show you. Oh, I see a comment. We have forgotten one thing actually, and I got you here again. We haven't set the previous row to be equal to the new row. Yeah. There we go. Done and done. So, yeah, nice. A shocked face. I like it. I'm very happy for the people staying here until probably 7 something. So, now we're actually making sure after we've gone through all the columns of that row, we set the previous row we have stored out here to be equal to the new row we have created. Yeah, so John?
Don't you need to initialize the size of the new row, seeing as it's an array?
Ah, yeah, good question. Oh, you're sorry. Yeah. The thing is, what have we said about anything but primitives? They're just addresses, right?
Yeah.
So when we write new row equals to previous row, we just give the previous row address to the new row, right? So this is pointing to this place in the memory where we have this memory set up already.
Okay.
I can show I've shown this a few times, but just a quick demonstration. We have this memory storage 1, 3, dot, 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 and what, whoops, let's move this a bit, and what previous row is pointing to is where this array begins, right? Whenever you write 0 or previous row 1, you're essentially pointing to this place in the memory and then adding this here. So if it's 0, you'll start here. If it's +1, it will go to this place in the memory. If it's +2, it will go this place, etc., etc., etc. But it's pointing here in the memory. And when you do this, the new row will do nothing more but to point to this same place in the memory. Which might be a problem, actually, now that you say so. Oh, goodness me.
Isn't the old array replaced by the new one, which is created?
Yeah, we should replace this because currently we are still pointing to the same place in the memory. Thank God you said this. So, is there any way we can get around this? And I'm just going to cheat here. You can create for loops, etc. I'm pretty sure clone would be good enough here. We can take a look at what this does. Array clone Java. Docs.oracle. No.
You typed close instead of clone.
Oh, sorry. Here we are. Essentially, yeah. So you can look up very easily, or just look at any of these random pages which tell you what it does. And they say contains the same elements as the source array. Perfect. So if we clone the array, hopefully we get a new copy, and hopefully when we run the program, we're getting something looking clean. Wow, yeah, sorry, this took a lot longer than I hoped. But yeah.
If we don't clone, maybe can we, like we are increasing the size of the row, right? When we have a new row, we are increasing the size of the row, don't we? So maybe we can include that in that statement, like previous row.
Well, we're never increasing the size of the row. The size of this previous row will always have 20 elements in it, right? So because what happens with arrays when you write this equals new int 20, for example,
yes,
or n rows, is that we say to the computer, all right, all of this is dedicated in the memory. You can't touch it. This is our memory. And even if we just fill the first elements, even if like we fill 1 and 3, the rest of these will be 0.
Okay.
And whenever we clone it like this, what we're essentially doing is that we're creating a new array with the previous values. And then, for each of these iterations, we essentially write one more number than last time, and then one more number than last time, until the last iteration where the array will be filled with elements, no zeros.
Okay.
Did that answer what you?
Yes. I'm still thinking about it, but yes, I understand what you explained.
Okay, so the array, yeah. Let's see here. I mean, we can try to fix the formatting a bit if we want.
Because the way I was seeing it is like I was trying to visualize the pyramid, and even though we determine like it's going to be 20, but I think the 20 row is what we're going to have at the end, like at the bottom. That's what we have, right? So the previous row for me is short. The new one that we create is longer if I try to visualize it.
The new one we create is longer. No, the thing is, so the size of this will always be 20, right?
Yes.
And then we create a clone. So this is the first iteration. Then our new array will be 1, 1, and then 0, 0, 0, 0, 0. And this clone will still have the size of 20, but just filled with zeros, right?
Yeah, I understand that.
And then we send this one here. So we'll get 1, 1, 0, dot, dot, dot.
And we keep on filling it up.
And this one will then have 1, 2. When we clone it, or when we fill the new array, sorry, it will have 1, 2, 1, 0, dot, dot, dot.
Okay.
And still have the size of 20. It's just that we're not using the other numbers, which are, so all of these numbers are not used during this iteration. And then all of these are not used, and then all of these are not used. You understand what I mean? So the amount of numbers not used decrease by 1 each time we go through this. But eventually, when we reach the final row, all of the numbers in our array will be used.
Okay.
Does that make sense? Did
Yeah,
I
yeah,
help
yes.
visualizing it?
Yes, yes.
Super. Then I'm gonna remove this forever. Now then, we can do some extra formatting if we want, which can be quite easy. Perhaps, you know, when we add the numbers and print them, we do something looking like this. We just add a space, so it's, you know.
Yes, please.
You can separate these. Beautiful, beautiful. Now we're reaching something. And then you can see that the tilt, it's very tilted like this, instead of having any kind of triangle shape. It's more of a Pythagoras triangle, if you know what I mean. That's not what we want. We want the pyramid, which is why I'm calling this Pythagoras pyramid.
I get you.
And does anyone have a suggestion on how we can format that?
Well, format, print format, something like that. Print out, system out, print format.
What do you mean? Yeah, okay, so I'm not gonna do this now, but the simple way, which I recommended in the solution, is to use something called String Builder, which I think we mentioned in one of the lectures. String Builder, you can easily just, and this will also be less demanding from programs, sp.append, and then you can, no, wait, I think there's even a
Offset, isn't it?
I think there's the, yeah, I'm not sure if it's offset.
No, I think.
I'm very certain there is a method here to just add a bunch of empty spaces if you want. Yeah, exactly. So, but someone got this right. So the easy way should be to find this method. The other way is to just create a for loop and fill it with empty spaces before you like print it, right? So just if we're at the first column, we should add the number of rows divided by 2 amount of spaces, for example. But for the other students, the previous iteration, I made it even worse because then they need to take into account how these digits increase in size, which means the pyramid will get even more tilted with time no matter what. So then you have to account for that as well, but we're not gonna even get remotely close to that. But this is the way to do it. If you get this triangle, you're done more than enough to actually, you know, reach a good point here.
There is an insert with an int offset and an int I. So I'm not sure if that works though, because I used it.
Does it? The offset?
Yeah, I didn't try it because I went with the 2D array, but you say that's not very, you know, takes too much space. So
no, the easiest way is to do it with a 2D array. No, not the easiest, but yeah, that's easily done. Then you easily fix the formatting here. But this can be done this way. The insert will just add something at some certain point in the array.
yeah, and there's one for ints as well. So yeah, there's first one, int offset I. So there, would that work?
Well, we can take a look at the documentation if we want. Can't remember what the shortcut was on Mac. Not that. I might break my computer. No. I'm pretty sure all this insert method does, but we can check the documentation, is that
that's the string representation of the second int argument into the sequence.
yeah, it goes to the, this is not the documentation. Here we are. Yeah, so it will be inserted at the indicated offset. So let's say we have the array hey. If you insert it at the offset 1, we'll skip 0 and it will HIEE, right? So it's not going to append any larger amounts of. Yeah, thank you, Cosmin. And thank you, Kavya. And everyone else I perhaps missed.
Likewise.
I wish we had more time for the recursion, but yeah, there might not be too much time for that.
It's 7:20.
I have a problem, I know.
No worries.
What about the system out format?
Sorry?
Oh, are you gonna do the?
Yeah, I'm not sure what you said about the format.
Yeah, for the formatting actually. There is a system out format.
Mm-hmm. And what does it do?
That could be used to format this actually, the pyramid.
1 second. System. But I'm not sure it would take into. Well, we had to use a string builder then, and then try to use the format thing. But I feel like that implementation will take some time.
It doesn't involve the string builder, but yeah.
I mean, if you're using system.out.print and then system.out.format, I think you call it.
Yes, system.out format, and then you have to put in quotation mark one of those things. I don't know how you call it, but it's the modulo sign plus some digit D plus the value that the variable that we want to print, which is V in our case.
Yeah, but I don't think that applies to formatting of the whole pyramid. It might just fix each individual print.
Okay.
Unfortunately. So the easiest way to do this, but the formatting is it should be quite easy to do on your own. Just create a for loop or find some of these methods you're suggesting. So I just want to give a quick feeling for how the recursion would go. We don't have to actually implement it.
Okay.
So recursion is all about, yeah, let's just do that.
Heading out as well. Have a good evening, guys.
All right. Have a good evening. Sorry that it became so much.
No problem. No problem. It's good to see everyone. See you guys tomorrow. Have a good evening.
Yeah, see you. Have a nice evening.
Thanks.
So, how many are we left? 7. Okay, I like it. 6 people. Recursive implementation is not very difficult when you get the hang of the concept. But what you usually will want to do when doing this is to have a method which calls upon itself. So having something public, static, recursive triangle, int row, int col. And then usually we want to have some other data you're referring to as well, but let's leave that for now. Sorry, there we are. And usually you want to see that you have some edge case scenario. So like if row equals 20, 21 in this case, we have some condition, and we also have some condition. For example, if col equals 0. Wait, let me think for a second. So column equals 0, that shouldn't be a problem. No. If column is greater than the row we're at, so column here equals row, but if column goes out here, we shouldn't fill any values. We shouldn't print any values, shouldn't do anything, which is also an edge case scenario where we should do nothing. Just return, we can say. We don't have to do anything. And in this scenario, if we're outside, we want to do return, right? Columns equal to row. No, sorry, my bad. So if column is equal to row, we will always want to return 1, which we easily can do. There we are, sorry. Whoop. And if okay, sorry, I'm just thinking about the edge case scenarios. So what you want to do is you want to see that when the row column equals to row, it should return 1. When the column equals to 1, this is also a scenario we can check. If col equals to 1, we just return 1. So now we have said in these scenarios we'll return 1. When we're outside here, outside of the numbers we're looking for, we just return 0. Otherwise, we can do something like this. So if none of these are true, we just
One question, Johan. It would be possible to do it with case 1, case 2, case 3, like a switch or what?
You could do it like a switch, but the reason I'm kind of doing it like this currently is that we can, when you do this code properly, you can remove a lot of these different scenarios, right? You can just remove them because like this one doesn't need to be checked, for example. We can just return 0 at the end of the program. So then we can have this we're doing now inside of one of these and then be done with it. But yeah, we can do it inside the switch as well if you want. But we're not going to implement the whole thing right now. We're just going to show what we're trying to achieve here. So let's say in our other implementation, we create int, and we create a matrix this time. Int pyramid equals new int da-da-ding, with the size of our rows equals to 20, and then we go in our rows and our rows. We create a pyramid of the size of 20. So 20 rows and 20 columns in this matrix. And perhaps we can have that sent in here as well. So we give the sorry. Oh, sorry, I see what I did. There we go. And what do we do then? We just call upon recursive triangle with the value 0. Uh-oh, we might have made some problems here. Hold on just a little second and let me think here. There we are. So we're calling upon this recursive triangle. And what essentially recursive triangle will do is to check these edge case scenarios. And ooh. I see what we've done wrong. Oh no. Oh God. If col equals row, we return 1. If col equals 1, we return 1. If row equals to 0, we return 1. And then we send in the row 20, column 0. Okay, I think this will do. Perfect. And then we finally add, if none of these conditions have been fulfilled, since we will return from all of them, we say that pyramid row comma col plus 1
Yes.
equals 2. I think here recursive triangle ooh, no, sorry. Pyramid row col equals 2. Recursive triangle I see what I did here.
2 minus.
Sorry? So what we're trying to do here, we need to go upwards down. So that's one of the key problems here. We want to return these edge case scenarios. I'm going to start somewhere looking right here. Last time we did this together, we sat up a Friday evening until like 9 o'clock in order to get this working properly. And we're not going to do that now. But what you need to do is that you need to
decrease the row, increase the column, no?
Yes, exactly. I mean, I'm just recursive triangle, pyramid row col equals recursive triangle.
Row minus 1 and plus 1.
Comma col, right?
Plus 1.
We're here, row minus 1. So let's say we're starting here.
Okay.
So then we want to go down the row, but stay at the same column.
Yes.
And then column minus 1, right?
Yes, yes, yeah, for this, yes.
And for the other, we want to take row minus 1 and just column.
Isn't column changing?
Now the column value is just, okay, so I'll clarify what we're written here soon. It's not, the code isn't correct yet, just beware of that. A warning to all of our listeners, viewers across the country and around the world. What we're doing here let's clear out our drawing. It was nice. No, we can't clear it out because we're gonna need it later to explain a few things, but I'm gonna move it here, and this we can just delete. So what we're doing here is that recursive triangle, whoop, it looks in the corner. If anything, we should make sure not to start with a 1. We have to do this for the whole first row. There's a way to do this, but whatever. Let's say we're at 3 currently. Let's say we send 20, 1, or in this case it would be 0, 1, 2, 3, 1. Yeah, nice. We want to figure out what this value will be. Then what you do is that you say, oh, have we missed something? It's complaining here.
It should be return, yes.
Okay, nice. Okay, perfect. So what we're doing here is that when we're at this value, we're checking, are we at row 0? No. Is the column equal to the row? No. Is column equals to 1? No. No, equal to 0, sorry. There we go. And to clean this up even more, as I mentioned before, we can do something like this. Or, how do you do or now again? Mac, please.
The or?
Yeah.
I think is option 7.
Ah, found it. Perfect. Thank you. So if the row equals 0 or the column equals 0, we just, well, if the column equals to row, we return 1. Otherwise, we go down 1 row and down 1 column. So we're trying to figure out what this value is. This value gets the value of what this value here is, plus what this value here is. And here we'll return 1, so then we can insert 1 here into our little pyramid. So we're setting this value to be 1. We're getting 1 here on the first call. And the second call, we see, uh-oh, we're not at row 0, column 0, or, here. Then we create 2 other recursive calls. So we check this value, and suddenly we see, uh-oh, perfect, we're getting 1 and 1. So then we return 1 and 1 here, which means that recursive triangle here will return 2. Then this will go up another method call and return 2 to here, where 1 plus 2 will equal 3 and will be inserted into the pyramid, right?
Right.
Then you have to make sure to do this for all the first rows, and then you have essentially fill the pyramid with the values it's needed, and you can create the recursive implementation for that as well. Turns out all for loops, etc., in the end are just recursive implementations, but they've hidden that and done it in other things to make it more easy for us to understand. And turns out we can also remove this if the row equals 0 is not the condition we need to think of, which means that we can move this condition here, do something like that. And perhaps we can even do pyramid all equals 1 if we want. We don't have to. We should probably not do that, just to make it easier to read. This is the simple code we will have when we have cleaned this up. And let's move this there. No. Okay. That's no. Why is it doing this? Okay. Perfect. There we are. So this is the simple part, and then we need to make sure to do this for all of these, and to make sure to actually print the pyramid. But recursion on its own is like a really fascinating concept, which you can get stuck in when trying to implement things like these later. Anyhow, I'm very sorry that this had a very slow start.
No problem.
It's 1940, and my family is probably wondering where I am.
Thanks so much for this effort.
Do we have any questions on how like recursion as a concept works?
Understood. I will have to go through the code again with the new understanding.
Yeah, we'll have to finish that implementation later and send it.
Yeah.
Okay, guys, I will try to upload this long ass video so that others can see. But I wish you a great evening.
Thank you. You too. Thanks a lot for the effort. Bye-bye.
Bye.
Thank you, guys. Thank you, Johan.
Bye-bye. Bye-bye, guys.
Thank you. Bye.